This video covers part 2 of Pre-Calc Notes 2.1. If you remember, we left off talking about expanded form of a quadratic and standard form of a quadratic. And standard form was the same form as vertex form. So if I have a equation that is in expanded form and I want to change it to standard form, remember the generic form of standard form is a times x minus h quantity squared plus k. So in order for me to get my polynomial to look like this, I'm going to have to complete the square. Now when we complete the square, we'd like to have the x squared term be just a 1, so we may have to factor first. So the first thing I'm going to do is I'm going to group my x's, put a blank at the end of it, and I'm going to move the 19 over to the other side of the problem, and I'm going to put my blank on this side to balance out my equation. And then again, because this is not a coefficient of 1, I have to factor. So to make it be a coefficient of 1, like I said, I have to factor. In this case, I'd have to factor out a negative 2. So it becomes negative 2 times x squared minus 6x plus blank. And so then I'll go through and I'll do the completing the square process. Remember, the formula is half of this middle term, negative 6. Half of negative 6 is negative 3. Then I take negative 3 and I square that and I get 9. So in the blank I'm going to put a 9. And then to balance the other side, I don't put a 9 in the blank over here, only because of the fact that I'm not really adding 9 to my problem. I'm really adding negative 2 times 9 when I put it in the blank here. So that's really negative 18. So to balance my equation, I have to put a negative 18 over here. And so now I can go through and I can complete the square on this side. I know this side will give me a positive 1. Over here, it'd be negative 2 times, remember how I wrote this up here as a negative 3? Because when I factor and I say what multiplies be 9 but adds be negative 6, it'd be negative 3 and negative 3. So that's why it's x minus 3 quantity squared. And then to get it so that it's in this form, again, I've got to get my y in my equation, and that's, I didn't really put it over here, I left it out. But that means I have to move the 1 away by subtracting. So then I would get my equation to be negative 2 times x minus 3 quantity squared minus 1. And that would be the standard form or vertex form of my equation. Now it's pretty easy for me to go through and find the vertex if the problem asks me to do that. I could say that my vertex would be a positive 3 and a negative 1. Typically where I see mistakes being made when we complete the square is right here. You're going to forget that in order to complete the square you have to have this be just an x squared, and you're going to forget to factor out. So if you don't have a coefficient of 1 with that x squared, you have to factor out to make it be a 1. And then the other mistake that I typically see being made is what we put in the other blank here. We don't always match the blanks up because really I'm adding a negative 18, so to balance, that's why that's negative 18, but this is a 9. Okay, so let's look at another example of where we're trying to change it from expanded form to standard form, or again, that's the same as vertex form. So just to remind us, this is the form I'm trying to get my problem to be in. So again, I have to complete the square. So what I'm going to do is I'm going to group the x's together, and I'm going to put a blank at the end. I'm also going to move the 1 over to the other side of the problem. So I'll have 1 on this side, and then I'll give myself a blank on that side as well. And this time again, because my coefficient is not 1, I've got to factor out a 3. So it would look like this. X squared plus, when I take 4 and I factor 3 out of there, I get 4/3. And then again put my blanks down so that I know what I'm going to be putting in the blanks. And now when I start the completing the square process, I take half of this middle term, 4/3. Well, half of 4/3 is 4/6, which is 2/3. And then I take 2/3 and I square it, and that makes 4/9. So I'm going to put 4/9 in this blank, but that's not really what I'm adding to the problem. I'm really adding 3 times 4/9, and 3 times 4 ninths is 12 ninths. And if I reduce that, 12 ninths is really 4 thirds. So I'm going to be adding a 4 thirds over here to this blank. And so now I can add these together. This would make 7 thirds. And this would be over here. If I complete the square, I could ask myself what multiplies to be 4 thirds, but, or excuse me, 4 ninths, but adds to be 4 thirds. I don't really have to do that because I already know what my answer would be. It should be 2 thirds here. So it'd be x plus 2 thirds, quantity squared. And the last thing I want to do is bring this back over by subtracting it. So my y would be equal to 3 times x plus 2 thirds minus 7 thirds. And I forgot to put my squared on there. And so this, again, I could look at this, and if the question asked you what is the vertex, now that it's in vertex formula, or vertex form, you'd say it's negative 2 thirds, because remember it's minus up here, and then negative 7 thirds. Okay, for this next one it says write the quadratic function whose graph has a vertex of 2, 3, so a vertex is my hk, and passes through the point 0, 2. So if it passes through this point on the graph, that's just an x comma y value. So I'm going to use the standard form. The reason I'm going to use the standard form is because I have the vertex. So if I plug into the standard form what I know that my h was 2, I know that my k was 3, and I know this xy value is 0 and 2, so y would be 2, x would be 0. All I really have to do then is solve for a, and then to be able to write the equation, what I really need in this formula is I need a and I need hk. And I already have the hk portion, so really all I have to do is find a. And then I can go back in and I can plug it in for, you know, if I know a, I know h, I know k, that's all I need to be able to write my equation. So let's take a look at what I get when I plug these in. So if I do that down here, it'd be 2 equals a times 0 minus 2 squared plus 3. So algebraically we'd first do this. 0 minus 2 is negative 2. Then I square that and I get 4, so I'm going to write it as 4a instead of a4. And now if I solve it for a, I'd get rid of the 3 by subtracting. And I'd get rid of the 4 by dividing. And I'd find that a is negative 1/4. And since I have a and I have hk, now I can actually write the equation. Now when I go back to write the equation, I don't put anything in for the x and the y. I'm only replacing what I've highlighted up here, a, h, and k. And that's usually a mistake I see students make. So if I would just replace the h, a, and k, it'd be negative 1/4 times x minus 2 squared plus 3. So this would be the equation that contains the point 0, 2 and has a vertex, as I can see, of positive 2, positive 3. Alright, let's take a look at this next example. It says the perimeter of a rectangle is 400 feet. Let x equal the width of the rectangle and write a quadratic expression, or quadratic function that expresses the area of the rectangle in terms of the width. So right away, here's what I'm given. I'm given the fact that x is the width of the rectangle. The perimeter is equal to 400. Okay, so if I have a perimeter formula, I know that the perimeter is really equal to 2 of the widths plus 2 of the lengths. And let's plug in what I know. So far what I know is that p is 400. I know that the width we really are using is an x value, so not w. And I don't know what the length is. So if I want to find the area, I know that the area formula is this. For a rectangle, it's length times width. I can use this perimeter formula here to help me figure out what the length is, because I already know what the width is. I already know that the width is x. So what I'm going to do is I'm going to take this equation right here and solve it for L. so that I can actually have L in terms of x, and I can replace then that in this equation. So this equation will have all x's as my variable instead of l's or w's. So let's solve this equation for L. So I'd subtract 2x. So 400 minus 2x is equal to 2L. Then I divide by 2. I get 200 minus x equals L. So let's put that into my formula here. Area equals the length, 200 minus x, times the width, which was already x. So with that being said, that leaves me then to find then that the area would be equal to, if I use the distributive property, 200x minus x squared. And this is a quadratic. If it's helpful to you to switch the order so you can see that, it'd be negative x squared plus 200x. Well, here's what I know. As I think about this problem, I'm trying to find, it says, of all possible rectangles whose perimeter are 400 feet, what are the dimensions of the one with the greatest area? This is going to be a quadratic that's going to be opening down because of this negative. So my graph is going to be something like that. If I want to find the greatest area is going to occur at the maximum value, which would be the vertex here. If the parabola was opening the other way, if the parabola was opening up and down, then it would occur at the minimum value. And that would be actually the smallest area. But I'm dealing with the greatest one, so then I'm going to find the maximum value. So all I really need to do then from here is I need to find the vertex. If I can find the vertex, then that will help give me my values for x and y, which are really my length and my width. There's a couple of different ways you can find the vertex. The easiest way to find the vertex when it's like this, when it's in expanded form, is to use the vertex formula, which is x equals negative b over 2 times a. So if I do that, negative b would be negative 200 over 2 times negative 1, and this would give me negative 200 over negative 2, which would be 100. So my x value would be equal to 100. And remember, x is really the same as the width. So I could say that my width would be 100. I still have to find my length. And so my length can be found then by plugging in to get the y value of the vertex. I'd plug 100 back into my original equation. A is equal to negative 100 squared plus 200 times 100. And so if I calculate this out, I'm going to end up getting my a value to be equal to 10,000. And I'm just realizing here that if this is 10,000, then I'm not going to get a perimeter of 400 feet. So I really didn't have to do that last part. I just needed to know the x value for the length, or for the width. And instead of plugging it back into here, if I want to find the length, plug it back into the perimeter formula that has length in it. This doesn't have length in it. So at this point, we should plug it back into either the perimeter formula or where we solve for L. 200 minus 100, because that was my x, equals L. So I'd get L to also be 100. And that would make sense because if I use my length as 10,000, I wouldn't get a perimeter of 400. But if I have a length of 100 and a width of 100, and I plug it into my perimeter formula, isn't 2 times 100 plus 2 times 100 400? So if I have a 100-foot length and a 100-foot width for my rectangle, that's going to give me my perimeter that I was looking for, perimeter of 400 feet. So that's going to give me the one that has the greatest area. The area would actually be 10,000. I didn't really need to find that. I needed to find the individual length and the individual width. So again, to just kind of sum up what I did here, I had to find only the x value of the vertex, and then to find L, plug it into this equation here. So my answer is 100 feet by 100 feet.